Hello, everybody. So, starting into week 2 here. Name in real quick. Probably a couple other people coming in the last minute as well. So, starting into week 2, this week we're going to talk about hardware. So, today's probably going to be a fairly short day in class. When we're in the classroom all together, the hardware section can stretch out a little bit longer because then we can pull out the tools and have a few old machines around we can take apart and examine all the stuff, but it's just not quite the same on a Zoom call, right? I can talk about hardware the same and show you all pictures of computers, but it's a little different when we can do stuff. So as we talk about things, it'll probably be kind of a short day today. I got a few odds and ends on the notes of things to talk about. One thing that I thought it was on my notes for last week, but I think I forgot to talk about it, and that was some stuff with the Word document assignment. I think I've seen those from most everybody now. I'm pretty laid back with those. One of the things I meant to say about that was I grade it from the rubric. So if you want to do your own thing, a couple people did do this, and I know I told a couple people personally, but I meant to say it in class. If you want to do your own thing on like the Word document and, well, the PowerPoint that is your own thing, and all those assignments, I'm just going through the rubric, clicking checkboxes. So as long as I can click every checkbox there in the rubric, you'll still get full points even if you do your own thing. It's just the confirmation assignments, those things that we want to take for granted in all of your other classes as you move through the whichever IT program you're studying specifically. Want to make sure that if somebody says create a Word document and do some stuff, you know how to do that. So, and it looked like just about everybody got the full check marks on those, but I still wanted to mention a couple things, so we'll throw that in here today, and then get started talking about hardware. But again, it's just kind of talking about it, and it's a little bit different when we're in class, so that'll probably make it a short lecture today. There's not really a whole lot of hands-on stuff we can do. And that's what the lab is this week. You'll go into your own system and pull up some information on the hardware you have, and there's different ways to get to it. So on all the questions on the lab, it's like, what type of CPU do you have, and who made it, as well as where did you find that information at, just for the one more review in the learning process to make sure you're well aware of how you found it and you didn't just accidentally stumble across the number and not pay any attention to it. So it should be a fairly straightforward lab. Everything's spelled out there. I guess I'll start with this one, which over the summer, the person in charge of, or not the person in charge of it, the department in charge of Ivy Learn, our ed tech department, they started adding a new module to some of the courses. And it wasn't here in the fall. It wasn't here when we started, but it's here now. So I wanted to point you towards this very useful thing. So in our course shell, if you go to modules, where we go to do all the homework and get to the textbook and everything, all the way down at the bottom, there's this extra one after we pass module 8, which will be the last week of the class. There's an extra module down here with just some useful links. So link to the email. There are these foundational assignments for the first 4 weeks. So if you want to install Microsoft Office, you do get a link. You do get access to that from the school. They have a license for you. So if you just follow that link, there's some instructions on where to download it from and a bunch of pictures and things, pretty detailed instructions, but a whole bunch of useful links like that all in one place. So if you go to our modules page and all the way at the bottom, y'all can look through there and kind of see what's going on. We do have a technology-oriented club related to the School of IT. There's some very proactive people in there. The club is constantly doing things, holding events and fun things. a number of people have signed up for that, but if you're interested in joining the computer club, let me know, and I'll get you put on that list. A couple other things. Those are just some useful links. I wanted to make sure and point those out to you so you would know they're there. Let's see. Okay, so I'll stop screen share. What's the next thing on the list? So, I have no idea why I put that on the list. There's something on there that is a little bit complicated for. It usually shows up in advanced classes. I'm not sure why. I might have put it on the wrong page. Yeah, it was probably supposed to go in the list for tonight's class. Oh, another one. If y'all were talking about homework or study groups are great, right? That's a great way to learn, because along with learning it, you're talking about it, communicating with your peers, and whenever there's problems arise, having to explain something to somebody else will really help you understand it. So study groups are good. If anybody was talking about like the labs and stuff, y'all might have noticed that there was a question on there that a lot of people were getting different answers for. Like, I had you log into the GRE labs there on campus. What GRE is, it's a Cisco thing. It makes us our own little private tunnel inside of Ivy Tech's network, so we can jump right on the main internet backbone and stuff. And we're connected to their network, but still completely separate from it. So it's like a little tunnel, not quite like, a little different than a VPN. Maybe you could say a very, very specialized VPN. We'll talk about those later, but it's like we have our own little private tunnel going through the network, like our own private wires and things like that. You can think of it that way. GRE is a Cisco thing, stands for a bunch of complicated words. Everybody just uses the letters. But on one of the questions on the lab was, is Hyper-V available on the machine? And if y'all might have seen each other's answers, you might have noticed that some people were saying yes and some people were saying no. And that's because that has to be set on the machine. So that's why I wanted to ask you all that one, so I have an idea of which ones I need to go in and turn it on for, so I can go in there. They should all do the same thing, but some of the hardware specific things like that don't come across when they just flash the standard software for the lab computers on there. Some of them might still have a few things turned off hardware wise. So I thought working that question in there would be kind of good. So then anybody that wrote no on that question, I can look at what machine you were on and go turn it on. Seemed like a quick way to do that instead of just going in and manually checking every single machine myself. At least narrow down a whole bunch of them. What that was, Hyper-V is graphics acceleration. So if you don't have a GPU, or if you want to use your GPU for other stuff, you can get better graphics out of a CPU with sort of make some modifications to the central processing unit instead of the graphics processing unit to improve graphics. So a software-based version of graphics acceleration. Let's see, we'll talk about hardware. Couple quick notes about the assignment that I think most people have turned in now, that Word document assignment. Like I said, I'm pretty laid back, so the main thing to look at on those might not necessarily be the instructions, but look at the rubric. Because when I grade it, I'm just going to go down to the rubric and click checkbox, click all the checkboxes. And I think most on those 4 foundational assignments, it is really a checkbox. There's like a box to get some points on that aspect on the rubric, or a 0. So it's like a bunch of yes or no checkboxes. So make sure you look at that when you're grading. I wanted to talk a little bit about the document thing. It was on my notes last week and kind of overlooked it. I guess one thing is I'm a Google Docs user. It looked like most everybody turned in Word assignment. That was sort of a standard assignment that I copied from the statewide course shell for this course. And it has been around for a while. it's been around for at least the last 5 versions of the statewide course shell of this course. So it's been around for a while, but we're just looking for basic document usage, and it's talking about Microsoft Word. But personally, I'm a Google Docs user, so I do most things on my phone. Probably noticed last week I have a bunch of different computers, but I still tend to do most of the stuff on my phone. And for like writing essays even, I'll just use the swipe text or sit back and dictate the first draft and then use the keyboard for editing it when there's not so many button presses later. Because it's a lot easier just to lay back on the couch and talk to the phone and have it write most of the essay out, and then it's just a little bit of editing to clean it up afterwards. So because of that, I'm a Google Docs user, and all the functionalities there, the same basic functionality. The main thing are the buttons are in a different place. But one thing that throws a lot of people off at first is, by design, Google Docs is, and the rest of the Google Office suite, it's intended to be transmitted across the network, whereas Microsoft Office is intended to be a local install, or you install the software on your machine and then you do everything right there locally. Well, since Google Docs is intended to be transferred across the network, I want to kind of minimize that, how much data is being transferred. So a lot of functionality is turned off by default. When you really dig into it, Google Docs has more functionality than Microsoft Word, but most of it is turned off by default. So you have to go in and turn it on. And they list them as add-ons, so you can add different add-ons. So what do I have on here? I'm constantly turning them on and off depending on what I'm doing. So something to write sheet music, and so sorting paragraphs, that's a very common button we'll use, right? Our bibliography, there's strict rules that the bibliography page has the thing, citations go in alphabetical order. And that's a lot more thinking than we need to do when a computer is perfectly capable of putting things in alphabetical order for us. So we can just write it out and sort the button. It's very useful when I point that out on Word at the same time, because a lot of people don't know that button, but right over here, this button on Microsoft Word, the A, Z with the arrow pointing down, that puts things in alphabetical order. So if I just throw in like a couple names here, Chris, Sally, just making up some names. Trying to not use any names that are here. Maybe I should do something other than names. Yeah. That way I'm not, it doesn't seem like I'm referring to anybody in particular. So like bird, truck, sandcastle, mountain. So when you have a bunch of words, you can just click that button, or a bunch of paragraphs. That button will put them all in alphabetical order. A very, very useful one. A lot of people might not know about. Might as well leave that open. But it's one of the ones on Google Docs that didn't make that initial cut because they wanted to minimize the data transfer, since that's sort of the design on it. And there's a lot of things. Oh, the easy bib. Speaking of bibliography pages, you can add a citation generator right in there. Anybody who's done some research reports has probably used EasyBib on their website where you're bombarded with advertisements and stuff. If you put it right in if you put the add-on writing Google Docs, you don't have to look at all the ads for it. And then just copy and paste web pages or DOIs. That's the serial number for every research report. Or whatever you have to get the information, and it'll just build the whole bibliography for you. Because that's just a bunch of grammatical rules to follow, and computers are great at following rules once they know about them. But for any Google Doc users or Google Office users, if you go to extensions and get add-ons, and you can write your own. It's basically written in JavaScript for anybody who knows a little bit of software development. We call it Actionscript. It's a very, Google did some customizations on JavaScript and kind of made it their own thing. But if you know JavaScript, you'll figure out Actionscript immediately. It's just a customized version of JavaScript. So you can write your own buttons if they don't already exist. Or if you go to add-ons and get add-ons, there's a bunch of useful things. Lucidchart, for those who have seen draw.io before, the sort of like drawing software, but it's for things like UML, Unified Modeling Language. We'll talk about that soon, where we draw flowcharts and use case diagrams and some very specific things that we're drawing. So we don't have capability to just draw from scratch like we would in regular artistic sort of graphics software. All the shapes we would need are pre-built. It's good for schematics, electrical schematics, or if you were making an oil refinery and wanted to draw the schematics for the refinery, there's some very specific symbols we use for that. So they're already drawn, so then we just drag our mouse around and we don't have to spend a lot of time drawing every single line because the shapes we need are already drawn. So you can put that right in there, draw pictures, easy bib, probably some table stuff. Hanging indents, that's a common one. Bibliographies are on my mind because I already started talking about that. I know I've seen that before. And then text cleaner. I'm not sure what this is. What does it do? You can go through and look and see what's going on with them. Something to clean things up. So if you don't like having all the links a different colored and underlined, you just want those as regular text, or adjust things. That's probably not something I was wanting. That's not what I was looking for. There's an add-on for hanging indents. Those are very useful. So you can just click a button. That's where the first line is all the way to the left and everything else is indented. So the opposite of our normal paragraph. The way we're supposed to write bibliography pages. Although if you use the EasyBib plugin, the EasyBib add-on, that will write all of that for you. Tables. Is there something about tables on here? Okay, yeah. So to get some nice looking tables, there's a whole bunch of things set up to make tables, or for programmers, you can add code right into your stuff. A lot of different add-ons, but a lot of people don't realize that's how Google Docs is set up. But since it's designed to be transferred across the network, across the internet, most of the functionality is turned off by default. So you have to go in and turn on the buttons you want. And it's just one click to turn them on and off. If you go to manage add-ons, you can see all the ones you have and turn them on and off as you need them. And you get a lot more functionality out of it. It's very, very useful. And I use Google Docs because I do most stuff on my phone. It's a lot easier just to swipe my thumb around or click the little microphone icon and dictate everything instead of spending a whole bunch of time typing myself. But we have all sorts of capabilities. I guess one really, really useful thing I like to show in Microsoft Word, since it looked like most people were doing the adding. You do get a license for Microsoft Office while you're here. And this will apply to all of them. There's a lot of buttons here. And sometimes when you're doing stuff, you might have to go digging around looking for the buttons, and you stare at the screen for too long. You might overlook things, digging through all the tabs. And for the buttons that you use a lot, or sometimes if you just can't find a button, you can customize this. You can make your own tabs. So I like to show that one. That was what was on the notes for last week that I apparently skipped over. if you go to the file menu, so go to file and options, then under options, one of the things is customize the ribbon. And this works for all of Microsoft Office. So over here on the left, you'll see all the buttons that are already there. That you might have to dig around through, but on the right is all the tabs. So you can just create.
I don't see options. Can you hear me?
What's that, Kaya?
Hey, I'm under file and I don't see
options. It should be under options.
What's the file?
File and options. You see it down there? Oh, are you using the online version?
Oh.
If you're using Word online, it doesn't have this. So this
I
just
need to be
local
into
install.
GRE.
But once you're in here, if you customize the ribbon, you can just make a new tab and give it some sort of name. Rename that, I'll call it class tab to find it again. And then the buttons have to go in groups. So in the new tab, you just select a group, or there has to be at least one there. And then just look for the button you're looking for the ones you commonly use. All commands. So we don't actually have buttons for everything Microsoft Word can do. Some things aren't even there, so you might need to turn some more on. Like I don't think any of the 3D modeling buttons are on by default in Microsoft Word, but Microsoft Word can handle three-dimensional models and put those into your Word document to make it look nice. The alignment buttons, maybe you have trouble finding those, and just add a few of the ones that you commonly use. I'm just going to click a few at random. Something like that. And the ones that you would most often use, change text direction. I just added a few at random. Change text direction, add that. There we go. So got those new buttons, and when you hit OK, that new tab should be up here somewhere. Oh, there it is. Got that tab that has your own customized one, which can also be a little bit easier too if you can't find the button. If you go in that way, you'll see all of them in alphabetical order, which will make it a lot easier to find a button and just add it to a new tab, and then you know exactly where it's at. That can be a really, really useful trick. For software developers, the most useful trick you'll want is Alt F11. This is where you would come to program a new button if one doesn't exist. We're not going to get into it a whole lot here today, but you can set up a little form. We have a text box and a drop-down menu and a button to click on, and then a place to write the code for what that button does. So Alt F11 is where you would come to do that, but this isn't a programming class, so we're not going to dive very deeply into that. So if there's not a button that already does what you want it to do, you can make one, or this saves as a macro. So if you regularly do the same thing over and over and over again, you can do your macros sort of repetitive processes. You can just set them up as a script. So that can be useful. That new tab one is incredibly useful and a great way to find, but if you have trouble finding a button, just create your own tab with the buttons you use most often, or when you go to look for something, the buttons are all in alphabetical order, which makes it a lot easier to find than digging through all the tabs and looking at the groups. And I guess the last thing I can say about Word is when you go look up official instructions, most people don't know how the instructions are written out. Because we're used to English, right? We read things left to right, top to bottom, but our instructions will be in a slightly different order. Anytime you look up instructions on stuff for Word, it goes tab, then group, and then button. So the instructions will say what tab to go on. So it'll say like the draw tab, and then it'll go to the convert group. So go from the top, then to the bottom to find the group you want, and then the buttons are inside of the groups. I've seen that confuse many, many people over the years, that it's like top, bottom, and then middle is how we read the instructions for anything in the ribbon. And, or in our modern world, there's videos available. But if you just check the instructions instead of a video, that might throw you off, or for anybody that has to take like any of the Microsoft Office classes. They're useful certifications to have, right? Whenever you go list out your certifications on the resume, it's going to look good to most businesses if you have like certifications in Excel and Word and
Hey,
all of that on there. Yes.
I have a Word certificate, Microsoft Word, but they never taught me how to add things to it.
Oh, there's yeah, the certification doesn't cover everything because there's a lot of different ones.
Oh, okay.
There's I can't remember the lower level, but there's like 4 or 5 different levels of Microsoft Word certifications. So I think that one's in the middle somewhere, like the 3rd level or something.
Yeah, I only have a level 2.
It's a very, very useful trick. That's one of the things I've found to be most useful in Word over the years. And and I guess the last thing on those, it looked like everybody turned in a Word document. So on those assignments, I just mentioned I'm a Google Docs user. So if you want to turn in the Google Office version, I won't have any trouble with that, or whatever one you use. So if you're, for the Mac users, if you want to use Pages and Numbers, and I'm drawing a blank on what the presentation one is, but the Apple Office suite, or a good open source one, if you like open source code, LibreOffice. This is a nice package. It's open source, which open source means a lot of people talk about the free version of that. That's what they advertise first. But open source means we get the source code, so we can modify that application to fit our needs precisely. So people heading into IT, you want to, well, free is always nice, but the open source is the bigger thing, because that means we can customize it to fit our needs perfectly instead of having to adapt to the software. But LibreOffice is a popular open source one that works on cross-platform. It'll work on all your systems. Free, I think it has the BSD license, which is the most open license there is the license that basically says do whatever you want with this software. So there's different alternatives, and if you want to use a different one, so the Apple stuff, Pages and Numbers, and I can't remember what their presentation software is called, but you can turn in those files directly. You don't have to worry about converting it to Office form, to Microsoft format for me. Or if you work on Google Office, send me the link to it. That's fine. That's the one I normally use anyway. You just submit the link in the comments or something to the document instead of downloading it and re-uploading it. I can work with any of that. Whichever one you prefer is the one you should probably be practicing with, right? So I would rather see you practice with the one you want. And if there's ever any issue, I'll let you know. But my Mac is starting to get it that reconfigured. Between semesters, I always do factory resets on machines, in part because I regularly break them in class in order to show people how to fix them. So between semesters, I always try to do a factory reset on all machines, and the Mac takes so much longer to reconfigure the way I like it after resetting. The Windows machine, the Chromebook, Linux, that stuff's all back up to my normal configurations and within an hour or two. But the MacBook, it usually takes forever, and usually about the end of the semester when it's almost time to do a factory reset on that one again. But I do have that, so whichever software you want to use is fine on any of those assignments. Then this week's presentation software, but since we just talked about Office stuff and office stuff's kind of boring. We'll talk about the presentation stuff on Thursday. Spread it out. Point out a couple little tips on there. Making slide decks and things like that. Our main topic for this week is hardware. That's a big part of computers, right? The physical device, the machine we're actually working with. I'll use these notes. And yeah, if we were in a classroom all together in the same place, I would pull out a bunch of machines we could take apart and look at the pieces and do stuff. But probably going to be a short day today as I just talk about some of this stuff, and then lots of lab time to actively do things. Because in the Zoom call, there's a lot of, in some aspects, I have to just show you pictures of computers, and you all know what a computer looks like. So let's talk about some of the hardware stuff. And for the lab this week, since we're talking about hardware, you're not going to be taking machines apart and putting them back together, physically fixing things. The lab is kind of looking through your system and finding the list of the hardware that's available. So you'll just list out like what CPU you have, how much RAM you have, and where you found that information. So I guess a good place to start is where we do our processing, where most of the stuff happens. It's gonna be our central processing unit. Central processing unit. So I'm going to draw kind of a rough picture here, big block diagram of some of the main components you want to know about. Obviously, this is an introduction level class, so we're not going to dive all the way into anything, sort of introducing it. But our central processing unit, or CPU, because that is kind of a mouthful to say every time. So we're going to use the acronym, and most everybody's going to know what you're talking about when you say CPU, even non-IT people. It's made up of several important components that work together. So one of the big ones is our control unit. I think I'll write them on the picture, and then we'll talk about each one. Another thing we need is a clock to synchronize everything. We'll talk about these in detail, but a control unit, it knows the core level machine instructions. There's a very, very short list of instructions that the machine actually knows how to carry out. And everything else is built up on top of the various combinations of those. Talk about that in a second. Then we have what's called the arithmetic logic unit, which I definitely don't have enough room to write in that box. The arithmetic logic unit, or a floating point unit, which are very, very similar. Those pieces do 2's complement addition on binary numbers. So that's where we manipulate the binary code. We'll do math on our numbers, or we'll use those to work in selection structures and check things, which is actually still math. So if we wanted to compare two things, all we do is subtract them. If we subtract them and get 0, that means they're the same. We list out all the binary representation of it and subtract them and end up with a positive number, that means the first one was bigger. If we get a negative number, that means the second one was bigger. So those handle the selections, and the math that we work on. I'm gonna kind of draw this a little straight. So we also have random access memory, sort of our main working memory. Then grab like a colored piece of shawl and sort of overlap with that a little. Something that's part of the CPU, but separate from the CPU. And hopefully that picture shows it's something different, but the CPU wouldn't work without it. That'll be our registers. So some of our main pieces internal to the machine and what they're doing. At least that's the ones just want to start talking about today. Wrong way for my hand. So the control unit actually I just wrote those backwards. The RAM should be out here. And the register's in here. Let me correct that picture, sorry. The registers are internal to our CPU, that main chip that all the magic happens on inside of the computer. And the RAM is separate, but the CPU could not work without it. So I like to draw a kind of overlap like that. So our control unit, it stores and retrieves all of the machine level instructions. I'm gonna write bigger than that, so you all can read it. So control unit is going to store and retrieve machine level instructions. And these are probably not the things you're even thinking of. So machine level instructions are like turn on the ALU, turn off the RAM temporarily, and the very, very basic steps of activating and deactivating these things in a certain sequence. There's a very short number of those that the machine actually knows. Our control unit keeps track of those. So as the program runs, I'll jump ahead a little bit. The program that's running would be over in RAM, and the instructions, by the time it gets to something that the computer knows, not that high level text stuff we write, it would just contact the control unit and say, turn on register 84, or increment the clock to the next cycle, and all that stuff. The small level things, which those are usually stored on ROM, which is read-only memory. The stuff that's set at the factory that we don't change afterwards. We can change it, but it's set at the factory, and if you're on a big complicated system, you might mess something up changing that. We're going to talk briefly about like microcontrollers and SBCs on Thursday. On those, they're smaller, simpler systems, so it's not so uncommon to go in and change the ROM on those that fit what we're doing, but we'll talk about that second. On our big fancy computers, like you joined the Zoom call from, you probably don't want to go in there and mess around with what's on the ROM yet. But that's the core level instructions that any program where you're running can ask for, and how we make things happen. Another big piece, so the clock there, that synchronizes everything. Synchronizes everything. And it's not like the wall clock we use to tell time. Right? Like on your computer, you have computer screen, you probably have a little clock on one of the corners, depending on the system you're on, with something that says it's 1:40 p.m. right now. It's not that type of clock. It's just a steady pulse. I'll just say pulse. I'm going to leave the word steady up there. A pulse to move to next step. It may not even be a steady pulse. It like the wall clock is going to run at a steady rate to keep track of time. But the clock just synchronizes everything. It just sends out a pulse and says, okay, it's time for the next step. And then all the instructions for the next step will carry, and then the clock will synchronize again and go and just align everything so that it moves to the next step. Then the piece that goes in here, a counter or instruction counter. The instruction counter is just a counter, something to keep track of what instruction we're on, so the computer doesn't lose its place, or in case we move around. Right? We'll open up our program and run instruction number 1, and when that's finished, the clock pulses and move on to instruction number 2, 3, and 4, and so on. And maybe when we get down to instruction 7, that says go back to instruction 3. So our counter, just like the clock, we have control over it. It's not just a steady incrementing thing. It's whatever it needs to be to make sure everything is synchronized to go in the order it's supposed to go in. We need a place to keep track of that, basically. Yeah, that's what I have in my notes. Just a simple counter to keep track of whatever instruction comes next. Not the current instruction. It always needs to be one ahead of us. We get into more advanced versions of CPU somewhere further down the line in introduction class. You'll find out the cycle is fetch, increment, execute. So we fetch our instruction, increment the counter, and then execute the instruction. Does anybody have thoughts on why it's important that it goes that order, as opposed to fetching our instruction, carrying it out, and then incrementing the counter? Why is it important to do to increment the counter before carrying out the instruction? Anybody have a comment on that?
So that knows how much to increment?
Yeah, to go to the right place. That example I made up just a moment ago, I said, what was I said? When we get to instruction 7 is to go back to step 3. So if we already incremented our counter, or if we incremented at the wrong place, right? Instruction 7 takes us back to step 3. And if we incremented, we'd be on step 4, not on step 3. So we're going to have to make sure follow that same pattern to synchronize everything. It's a very important one. You'll hear that in much detail further down the line in your studies, or for those heading on to like 4-year studies after this, when you get into, especially in assembly language, when you take a programming class on assembly language, you will definitely see a lot of that. But the order is very important. That the CPU just runs repeatedly through a fetch, increment, execute cycle over and over again to grab our instructions. So clock to synchronize everything. Okay, now I guess the 2 big ones, the ALU and the FPU. So I don't seem to have enough room. Is it okay if I erase this part? The words there and write the next set of words. Okay.
Sorry, I'm late.
Oh, it's all right. I understand life happens sometimes. It's like
That it does.
we get overwhelmed. Let's see, number 4, arithmetic logic units. I'll spell it out here. If I can spell correctly. Arithmetic logic unit, and floating point unit. Which both of them do the same thing. It's just the direction that the circuit's laid out in. I'll write a random number here. So
Can I ask a quick question?
what's that?
Can I ask a quick question?
What's that? Mason?
Are you going out of the book there, or I know those are your
No,
notes, but
these are just my notes.
off of chapter 1,
I'm
chapter
not sure
9?
where this would be in the book.
All right.
Where the section is.
All right, thank you.
It should be roughly around where we're reading now. I try not to follow the book precisely. So I remember a number of classes sitting in a class where it seemed like the professor was reading the textbook to us. It's like, well, I read the book before class. You got somebody to read it now. So I try to go beyond the book. I always try to teach more than I test you on. If some really good points show up in the lecture, things that seem important or things that I stress heavily, I might add questions to the quizzes and stuff, but generally I try to extend beyond what the book covers, taking the next couple steps, or give a different angle of it. So these two things, we have a number. I'll use the ones we're used to instead of binary code. So 3,472.583. And on our whole number part, the value kind of grows going that way, right? It grows as we go to the left. We have our ones, then tens, hundreds, thousands. But for the smaller, the fractional part, it's like it's growing this way. The tenths, then the hundreds, then the thousands. So as we line those columns up, which we're going to talk about binary at some point, then next week when we talk about data sum, we'll do a quick pass at it, a quick introduction to it. Our whole number portion kind of goes a different direction than our fractional portion. So we need two separate pieces in the machine that are identical, except one goes right to left and the other one goes left to right. You keep everything like that. That's why there's two of them, but they behave exactly the same. What those do is they carry out two's complement addition. Two's complement, we're used to seeing two and people think binary. That's an old math trick. It works in any system, but it cuts things down. We don't have to worry about negative numbers anymore when we use two's complement. So all we have is positive numbers, but if we need to subtract them, we modify one of them into a second rank of complement. So complement, not like complement with an E. So we're not saying nice things about our number. We're accentuating it, like complementary colors, or sort of the opposite. Well, in binary, it's definitely the opposite because we only have two options. If we have a 0, the only other option we could have would be a 1. So it's really easy in binary. But we take one of our numbers and we complement that, and then do a second rank of complement, a second operation to it. And then we have two positive numbers that when we add them together, we get the result that we would have got by subtracting it. We'll talk about it. We'll go through an example, like probably not going to ask any questions about it in this class. In your STEP 120 class, you probably have to answer questions on it. We'll walk through an example where we add and subtract numbers with it and see how that works. And the big thing is it makes all of our math one single operation. So no matter what math we want to do, we can carry it out from a single operation. We don't even need add and subtract. We can do everything from add. So in a computer, that means we only need one circuit to carry out everything. So those are the pieces that carry out the 2's complement addition. And one of them goes right to left for the whole number portion, and one of them goes left to right for the fractional portion. And when we're talking about data and how we store stuff, I was going to do a quick introduction to binary and some of what it means, and we'll at least do a quick example of 2's complement so you can see what that is there. But I guess the big thing is the 2 throws people off because they're used to binary. They think that's something specifically for machines, but it works in any number system. It's just an awful mess that we would never want to deal with in anything except binary. It's really, really easy in binary. Let's see what's next. Registers. It's okay if I erase these, or sorry, erase the words. That's what those are the pieces that do the math, and like arithmetic is in the name there. And so we can add and subtract and compare things. Because again, to compare things, all we have to do is subtract them, or add, subtract, multiply, divide, modulus, all our operations, exponents, all that stuff we know from math. And we can compare things, because to compare things, all we need to do is subtract them. If we subtract them and we get 0, they're the same or equal. And if we subtract them and get a positive number, that means the first one was bigger. If we subtract them and get a negative number, that means the second one was bigger. So it gives us ways to compare. And most of our processing will happen there. Things will send it through there and work with the registers. So registers and RAM. Registers and RAM, I'll write them both up here. RAM stands for random access memory. It's a place to hold things temporarily, and we don't have to worry about orders or anything. Just whatever spot is open, we'll use. Right? On your hard drive, when long-term storage, or our technical term for the hard drive, the long-term storage, the files that you hit save on, right? Like on your Word document, you write up an essay and hit save, and that goes to your hard drive. The long-term storage or non-volatile, which means it lasts, those have to be very specific. Okay? If we save something on the hard drive, we need to know exactly where it's at and exactly where it's always going to be. With RAM, it's randomly accessed. Whenever we need to put something in RAM, we'll just throw it in whatever open space is available there. It's the random access part. But our technical term for this is going to be volatile storage. Or in normal English, we would say temporary. It will store things as long as there is power supplied to the machine. When we turn off the machine or unplug it or the battery runs down, these that RAM and registers will no longer be storing the data. Otherwise, they're very, very similar. The big difference between them, at least for the introduction level here, there's a lot of differences in the long run, diving into all the details, but we're in an intro class here. RAM is our current program. And the registers are the current instruction or current step, right? Yeah. Our current step or instruction in the program. So a much smaller version. This will hold the whole, this holds the whole program, and the registers hold the current step that we're carrying out in that program. Oh, yes, and an important one for registers is this is like this machine size that we list. For example, I'll write it as an example. If we have a 64-bit machine, whenever we say we have a 64-bit machine, that means we have 64 bits in each register. Which definitely ran out of room there. So saying a 64-bit machine means we have 64 bits per register. Or likewise, if we have an 8-bit machine, an 8-bit computer means that we have 8 bits in each one of our registers. So that each instruction that we carry out has to fit in a register. So yeah, on an 8-bit machine, we can only carry out instructions that would fit in an 8-bit register. Or on a 64-bit machine, we can only carry out instructions that can fit in less than 64 bits. Each individual instruction, and then the overall program is probably going to have to be a lot longer than that, right? 8 bits wouldn't be very much of a program, but it's enough for one step in the program. Anything else in my notes here? Registers or temporary storage, data for the current instruction. It's the size of the machine. Two different kinds of registers. Yeah, I'll talk about those, and then probably a good time to take a break. Third place I can squeeze some notes up here. So our two main types of registers that we use are going to be either shift registers or parallel registers. And shift registers come in as a single line. I'll sort of draw a picture. So maybe we have a shift register, which is, it comes in as a single line. So we have one input, and then we have 8 outputs, well, 4 outputs. Definitely ran out of room. But on a 4-bit machine, so 4 bits in the register, we have one line coming in, which is called serial communication. All of our bits travel down that one line. And if we need 4 bits, we'll send in the first bit and load it in there. Then we'll send in the next bit, which shifts that down to the next one. Then the next one shifts both of those down again, and it just shifts over as we load the bits. And parallel registers, the bit, we have lots of ways to load it in. We have lots of inputs to load in. So we have a parallel register. We have like 4 inputs into that register, and keep this somewhat simple. I'll just do 4 inputs coming out, which is going to seem almost like a bus, but not like 4 lines. Things happen inside. Things happen inside of that register. I guess I could do kind of shifting and adjustment, because we also have that kind. So parallel, we would have 4 lines coming in and 1 line going out to serial. That's another kind, so maybe that works better with the picture. But a lot of times we would have 4 lines coming in and 4 lines coming out, and then stuff's gonna happen inside of that register. That probably works a little bit better for the picture. So those numbers will be important for the next part, but it's probably a good time to take a break before the next few things we talk about, right? Does that much make sense? That's the key parts of our CPU. That's the main chip on the computer that's doing all the work. We have this control unit. That's the read-only memory, the stuff programmed at the factory. It's the core electrical things that the computer knows, like turn on this piece and turn off this piece, and those sort of instructions are in the control unit. Then our RAM holds the entire program that we're working on. The registers hold the current step, and that current step will ask for one of those things the control unit knows how to do. We have a clock to synchronize everything, which isn't a steady pulse, it's when it's needed. And an instruction counter to keep track of what instruction needs to come next. So those are the core parts of the hardware on how things work. There's a little bit more on my notes to talk about, but probably a good time for a break. 10 minutes sound good?
Yeah.
All right, my clock says 2:01, so we'll get back to it at 2:11. And I'm gonna go grab some coffee because I'm getting thirsty after talking for an hour. Let's see, stop the recording.
I got a question.